number 80. What is the freezing point of each solution in problem 79? So you got three solutions. What is the freezing point? In the textbook, in the colligative properties section, you can read that 1 mole of solute lowers the freezing point of 1 kilogram by 1.86 degrees Celsius. So we're talking about a kilogram of water here. And the question is, what is the freezing point of each of these solutions? Well, water freezes at 0 degrees Celsius. If you have 1 mole of solute particles, then that freezing point goes down 1.86 degrees. If you got 2 moles of solute particles dissolved in the kilogram, it would go down twice this much. And that's how you figure it out. We have to figure out how many moles of solute particles we have, and that tells us how much the freezing point goes down. Well, the first one's pretty simple. You got 3 moles of fructose molecules in the kilogram of water, so 3 moles, and for every 1 mole, it's a 1.86 degrees Celsius drop, and so that calculates to give you 5.58 degrees Celsius drop, or 5.6 degrees Celsius drop. So the new freezing point is going to be negative 5.6. I should have rounded that. It's going to round right here. Negative 5.6 degrees Celsius. That'll be the new freezing point. Okay, part B, a little more tricky because this is an ionic compound. And if you got 1.2 moles of potassium iodide, remember when ionic compounds are dissolved in water, they dissociate into cations and anions. And for every 1 mole of these, you're going to have one of these and one of those. That's going to be 2 moles of ions. So if you got 1.2 moles of potassium iodide, for every 1 mole of potassium iodide, you got 2 moles of ions. And then for every, so this right here, this part tells you how many moles of particles. There's going to be 2.4 moles of particles. And then for every mole of particles, it's going to be a 1.86 degrees Celsius drop. And you can see how the conversions are strung together, and doing calculation gives you 4.5 degrees Celsius drop. So the new freezing point is going to be negative 4.5 degrees Celsius. The last one is sodium phosphate. Sodium phosphate. Here, sodium phosphate is another ionic compound. You got your metal and your polyatomic anion, your metal cation, polyatomic anion. This guy will dissociate to give you 3 sodium cations and 1 phosphate anion. So for every 1 mole of this compound, you're going to have 3 plus 1 is 4 moles of ions. So if you got 1.5 moles of sodium phosphate, for every 1 mole, you're going to get 4 moles of particles, the ion particles. And then for every mole of particles, it's a 1.86 degree drop. So you see the units canceling to give you degrees. And the calculation gives you 11.16, which rounds to 11. So the new freezing point is going to be negative 11 degrees Celsius. Quite low.